All right, guys, welcome to Quarantined Algebra 2 for April 6th. Now, I'm going to begin the video here in a second, but a quick announcement for you guys. This week, as you may know, is the week that was originally scheduled to be our spring break at Slater. And we still want to observe that, right? Like, you guys, even though you've been at home for a while now, I don't want to be overloading you all with work during that week of days that you're supposed to be able to do whatever the heck you wanted, right? So we're going to have videos on Monday and Tuesday of this week, but then Wednesday through Friday and then Monday of next week, our originally scheduled break, I will not be uploading videos on those days. So there's only going to be 2 days of videos this week, and then we'll start back in on next Tuesday. So if you don't see any videos, that's why. Now, what we're going to talk about today is this right here. Adding and subtracting rational expressions with unlike denominators. I don't really like the word bases for this. They're denominators. So, before we jump into these actual questions, what we're going to do is we're going to go with a pretty simple lesson about unlike denominators in regular fractions. So this honestly is probably a pretty simple topic, pretty simple video. Most of you guys probably already know how to do this, but I wanted to have this video, I wanted to go over this just in case. So I have three fractions here, or three equations. In all three of them, we have denominators that are not the same, but each of them work out a little bit differently. Now, what we want to do is we want to be able to make these to where the denominator is the same, right? Like, we can't add 3/4 and 1/2 because to add or subtract fractions, these two numbers, the two denominators, have to be identical. In some instances, we can turn one denominator into the other one. That's like this first example here, right? We have 3/4 and 1/2. We can turn 2 into 4 by multiplying it. So if this is the instance, you have two denominators where one can turn into the other, all we have to do is multiply one of them, but we multiply it by whatever it is that will turn it into that. So for example, to get 2 to turn into 4, we need to multiply it by 2, right? If it was a 3 and a 12, we'd have to multiply it by 4. If it was a 6 and a 30, we'd have to multiply it by 5, that kind of thing. You multiply it by whatever it needs to turn into the other fraction. But the important thing to know is, just like in all aspects of math, you can't just do one thing to a single part of the number, or single part of the equation, whatever it is you want to say. You have to do it to all parts, or both parts of a number in this case. So not only are we multiplying the denominator by 2, but we also have to multiply the numerator by 2. You always will multiply the numerator and denominator by the same number when trying to adjust these denominators. So 3/4 is not going to change, but 1 times 2 is going to be 2, and 2 times 2 is 4, so now we end up with like denominators. Now, you can tell these fractions are identical still, right? 2/4, well, that simplifies to be 1/2. They're the same number, they're the same fraction. We just now have it written so that it can combine with this one to be 5/4. And always do remember, when adding and subtracting fractions, only the numerators add or subtract. Denominator stays the same. Now our next example, 6/7 minus 7/4, is a little different because we can't turn one of these into the other, right? We can't turn 4 into 7 or vice versa. This is, in general, going to be the most common way this happens. What you want to do in problems like this, what I personally like to do, is I just multiply each denominator by the opposite denominator, by the other denominator. Meaning, I'm going to multiply this 4 by 7, and the numerator by 7 too, of course. And I'm going to multiply this denominator of 7 by 4. You can see that the other denominator to this 7 is 4, so that's what I'm multiplying it by. The other denominator to this 4 is 7, so that's what I'm multiplying it by. This will the majority of the time, I want to say like 9 times out of 10, is going to lead you to the least common multiple, the smallest number that both of these go into. That 1 time out of 10 it won't is what we're going to be talking about next. But that's still okay. You still want to multiply these. So this is a surefire method, even if you can turn one into the other, even if you just don't notice that for whatever reason. This method will still work, by the way. So I'm going to go ahead and multiply this by 4. Well, 6 times 4 is 24. 4 times 7 is 28. And then minus 7 times 7 is 49. And then 4 times 7 is 28. So you can see that we ended up with two denominators that are identical. Both of these ended up with a 4 times 7 for the denominator, or 28. Well, 24 minus 49 is negative 25 over 28. And there we are. We're done with that problem. Now this last one, the only difference here is that what most of us, I think, would do, myself included, whenever trying to make these denominators match, is go ahead and multiply this one by 6 and multiply this one by 8. However, whenever we do that, it's actually going to end up with a denominator that is not the least common multiple. But that's okay. It just means that we're going to have to simplify our fraction after we add it or subtract it, whichever the problem is asking us to do. So that's one reason you always want to take a look at these problems and think, can I simplify this before just calling it good? So for example here, 8 times 7 is 56. 8 times 6 is 48. Then we have 5 times 6 is 30. And 8 times 6 is, again, 48. When we add these, we end up with 86 over 48. You'll notice what I was saying here, that this fraction is not simplified, right? Unlike these other two, 5 over 4, negative 25 over 28, those are both fully simplified. This one's not. Those numbers are both divisible by 2. So I can go ahead and do that. 86 and 43, sorry, 86 divided by 6 will be 86 divided by 2. Sorry, I don't know what I'm saying. Is 43. 48 divided by 2 is going to be 24. And now we have a fully simplified fraction. What you'll actually notice in this fully simplified fraction is that denominator is the least common multiple of the two. So technically, instead of turning these into 48, we could have turned them both into 24, meaning we would have multiplied the 6 by 4 and the 8 by 3. But that's a lot more work, in my own opinion, to try to come up with, to try to determine, okay, well, what numbers am I going to have to multiply these by to make them the same? I prefer just multiplying them by each other and simplifying later. That's my route to do it. So this is the idea behind making denominators match. So when we look at problems like this, where we have 2x and 3x, then we have to ask ourselves, well, what can we make both of these turn into, right? Do we multiply each of them together and end up with 6x squared? Do we maybe just multiply that one by 3 and that one by 2 and end up with 6x? What can we do? Same thing here. These are the questions we're going to be answering tomorrow, though, in our final day of videos before spring break. So, if you have any questions, let me know. Otherwise, I'll see you then.